So again, you just want to make sure that when you type in that table, it says X1 and it says Y1. So let's type it in. So we've got 0, 13.7, 1, 13.12, 2, 12.71, 3, 12.34, 4, 11.92, 5, 11.46, 6, 10.96, 7, 10.45, 8 is 9.94, and then 9, we've got 9.53. Okay, so I already typed in my linear and my exponential models. Again, once you have that Y1 and X1, you don't have to retype these every single time. You can leave the models in there and then just edit your table. So for the linear, I'm going to write all three of these down. So for our linear, we've got y equals, our m is negative 0.46x plus our b is 13.68, and it has an r squared of 0.9981, so that's super good. So let's look at our exponential. So the exponential, we've got a is 13.77. So y equals 13.77 times our b is 0.96 to the x value. And it has an r squared of 99.35. So our linear is still winning. But let's try our quadratic. So y1 squealy ax 1 squared plus b x1 plus c. So this one we have an r squared of 0.9986. And so our linear was 0.9981. So really our quadratic has the higher r squared value. So let's write that one. So we've got our a is super small. So y equals negative 0.004 x squared minus 0.42 x plus 13.63. And so really, based on just the r squared, quadratic has the best r squared value. So for part B, we want to know, with each function found in part A, we want to predict the average number of insured commercial banks in 2005. So we want to look at linear, exponential, and quadratic and see which one has the most realistic prediction. So I'm looking at 2005. We started in 1987. So if I do 2005 minus 1987, I'm looking at 18 years later. So what I want to do is I want to take 18 and plug that into my x values in all of my equations and see what we get. So I'm going to just get rid of all these. So for my linear, I'm going to have negative 0.46 times 18 plus 13.68. So that gives me 5.4. If we do our exponential, we'll have 13.77 times 0.96 to the 18th power. So that gives me 6.6. And then for the quadratic, we've got negative 0.004 times 18 squared minus 0.42 times 18 plus 13.63. And so that gives us 4.77. So if we look at these, they're all pretty similar. They're all pretty close together. In this one, we're talking about the number of insured commercial banks, which you would think that most of them would have insurance. I mean, I would feel like that would be a requirement. So when it says the most realistic prediction, I would say for this one, we would go with quadratic just because it is the best R squared value. Now, if you think about a quadratic function, it's increasing and then it's decreasing, right? Because we have that negative. So we know it's going to be shaped like that. So eventually we would be going into the negatives. And we would with the linear as well. It has a negative slope, so it would be going down as well. So for the linear and for the quadratic, I would say eventually they wouldn't be a realistic prediction because they would be in the negatives. For your exponential, though, it would never be negative. It would just keep getting closer and closer and closer to zero. So maybe if we looked at an x value farther out, so maybe if we looked at 2020 or 2021 or something, again, the most realistic would probably be exponential because it would never be zero, or it would never be negative, where the other two would be negative. So again, you want to look at the R squared, but then you also want to think about what's the most realistic as far as the numbers themselves go and what the problem actually means. So of course, as always, if you have any questions about any of this, please let me know. I'm here to answer your questions. So feel free to ask them.